Good morning, dear students. Welcome back to a YouTube class. So in the previous session, we were dealing on the concept memory allocation of pointers. We had seen how we can allocate the memory to your pointers. So using your pointer concept, we can allocate the memory in two ways. That is static allocation of the memory and dynamic allocation of your memory. Usually the memory allocation is done in two ways, that is static and dynamic. The static is known to everyone. There is no need to use pointers here. Normally we can assign the value to your variables, or else we just declare the value variables of its particular data types, and based on that data type the value will be declared. So when you declare the variable, immediately in the memory, in the storage, the memory is allocated for that variable. Done. That is your static memory allocation. So in your memory allocation, we have totally two types. In memory allocation, we have totally two types. One is static allocation, and the second one we have is dynamic allocation. So what happens here in your static and what happens here in your dynamic allocation is, in your static memory allocation, it refers to the process of allocating memory during the compilation of the program, that is before executing your program. So when you declare your variable, for example, if you declare here as int equals int z, then immediately when you try to compile your program for checking your errors, that time the x has been reserved 2 bytes of the memory in the storage. Why exactly 2 bytes? I told you already, that is z is a variable of integer type, and integer type variable always needs 2 bytes of the data, because the capacity of int is 2 bytes. So 2 bytes of the memory will be reserved for your z variable. Then so such type of the memory allocation is called as static memory allocation. Then so this static memory allocation is no need to use pointers here. Easily you can do it. Then so the second type we have is dynamic allocation. What happens here in your dynamic allocation? The dynamic memory allocation refers to the process of allocating memory during the execution of the program or at the runtime. So here in your static, the memory allocation is done at the time of compilation, means before the execution of your program, where in your dynamic allocation the memory is allocated at the time of execution. At the time of execution, that is at the time of runtime, you can call it. So if your memory is stored or allocated at the runtime, then that process is called as your dynamic allocation. So here when you are referring the dynamic allocation in your memory, then the memory space allocated with this method is not fixed. Means if here in your static allocation you had declared it as int z, then before the execution we know that z needs 2 bytes of the data. Before the execution only we know that z needs 2 bytes of the data. Where in your dynamic we don't know how much it needed. When you execute and when we assign the keywords, that time only we'll get to know how much capacity of the data is necessary for that particular variable. Then so here in your C++, when you are using the pointers dynamic allocation memory methods, then we usually use two operators here. The one is called as new and the another one is called as delete operator. There are totally two operators we use in your dynamic memory allocation. Those are new and your delete operators. So here new operator is used to allocate the memory, that is dynamic allocation of the memory. When you want to allocate memory at the runtime, then that time we use this new operator. And when you want to deallocate the memory dynamically at runtime, then we use the delete operation. So new is an operator which is used usually when you want to allocate the memory dynamically, and delete is an operator which is used to deallocate the memory at the dynamically. Then so here these new and delete, there is allocation and deallocation, and for that purpose the operators which we use is new and delete. These operators allocate memory from the objects from pool, that pool of the memory is called as free store. The pool of that memory is called as free store. So free store, as I told you, is an area or a space of the memory, from where the dynamic allocation is taking place. That may be allocation or deallocation. Just both dynamic allocation, deallocation process can be taken. So when all you are performing the dynamic operation, allocation and memory allocation and deallocation, that time this new and delete operators always refer of using the memory from this pool. That pool is called as free store. The new operator calls the special function operator new, and the delete operator calls the special function operator called as delete. Means when all you want to perform the memory allocation dynamically, it calls new operator, a keyword new we use, and when all we want to dynamically deallocate the memory, then we go for using this delete operator. Done. So we'll see, we had seen already in detail relating to static and dynamic, and we had also seen new and delete. So it has been asked repeatedly for 3 months. So let me do a revision one more time. So we'll see new operator. So this new operator is used when all you want to allocate storage for a variable while program is running. Means when you are executing the program or at runtime, that time we use this new operator. To allocate the storage or to allocate the memory for your variables. Then, so it is also used to allocate memory without having defining your variables. Means if you are using your dynamic method, wherein you are static, we have to define the variables, and when you define the variable, that time only the memory is allocated. But it is not necessary for your dynamic allocation without defining your variables. We can assign the value, but for that what we have to do is you have to make the pointers. Point to those variables. Then, so here we can just give 2 lines of the examples as I had given you in the previous class. The example, int asterisk p, you can take it. Next we can say p is equals to new int. So what we had did here, the p is a variable, the pointer variable we had taken of integer type, and later the memory which we want to assign to that p, we made it as dynamic allocation by using this new operator. So what happens here, first line will tell you that p is a pointer, and second line tells you that it allocates the memory for an integer, and here the p is assigned the value from the memory using this new operator. Means we are doing dynamic allocation. Then, so as you can allocate the memory for a variable like integer, similarly we can dynamically allocate the value for your arrays also, and similarly for your structures also. We can allocate the memory dynamically using new operator for a normal variables. In the same way, we can allocate the memory for your arrays also and for your structures also. So arrays, how we declared is data type which you want, you can go. So I will go for here double asterisk ap array of pointer is equals to new double, I have to say. How much size you want, that much of the size capacity you can give it. Done. So here earlier it was written as p new int only, but here we had written double asterisk ap is equals to new double. Its size is, there is a space here, okay. Double, the size subscript is 50, okay. So this line we had not written, for that reason I am writing all together here. Then I cannot write directly ap equals to new double and the size, because I have to declare first this ap. So that one line we had not written, so everything in one line only we had written. Means two lines we had to write, and that we made it into only one line. So this is how we can declare an array memory with a new operator. Similarly, we can declare for structure also. The structure variables is also possible to declare dynamically. So how we can do that? I'll take one structure is called as student. Variable of the student we have to create means object of the student is SP, and then I say new student. I say new student. Done. So like this you can declare, allocate the dynamic structure variables or the objects. Then that is also possible. Clear? So this is how we use the new operator. Study this new operator separately for 1 marks and 3 marks. The memory allocation for 1 marks and 3 marks. And the next operator we have is, we had studied new operator. Now we will study about your delete operator. We'll study about delete operator. So the delete operator is used to destroy the variable space which has been created by using new operator dynamically. So when all we want to allocate memory dynamically to any variables, we use new operator. Now the memory which has been allocated by using your new operator dynamically, that memory we release after the execution of your program. And to release that memory, we use this delete operator. We use this delete operator to release the memory space. To release the memory space or to destroy the variables space which has been already created or already assigned or already reserved the memory space dynamically. Then, and this use of your delete operator is usually to free the dynamic memory. So you can use this delete operator with the variables. How you can use is just you have to write the delete keyword and the variables which all you are used in your new operator that you can go for. So I had used is normal variable as p, delete p if I say, then the memory which I had reserved for this p will be released or destroyed. Then similarly we can write the delete operator with the arrays also. So delete the subscript of the array and ap variable. So which variable you have used for the declaration, the same variable you have to use for delete also. Next, delete for the structure also you can do it. Delete structure or the variable of the structure, you can just write it. Delete student also you can say it. That is the name of your delete. Done. So just remember, study this delete operator for 1 marks and 3 marks. 3 marks is to explain the delete operator, and for 1 mark it is what is the delete operator, for what purpose we use delete operator. Like that we can get it. Done. So we have to study here in detail relating to the memory allocation, the types of the memory allocation, and which all the operators we use for the memory allocation, that is new operator and the delete operators. Now we'll see the new part, that is the difference between static allocation and the dynamic allocation. So now we'll see what is the difference between your static memory allocation and the dynamic memory allocation. So this question has been asked for 3 marks. Write the difference between your static memory allocation and the dynamic memory allocations. So the first point we have is, in your static memory allocation, memory space is allocated before the execution of the program. In your static memory allocation, the memory is allocated before the execution of the program. That means it is allocated at the compilation time. So we will write the first difference. Memory space is allocated before the execution of program. And here in dynamically, the memory space is allocated during the execution of your program. It is the reverse of the dynamic static. Memory space is allocated during the execution of program. Done? So the very first difference between your static memory allocation and the dynamic memory allocation is, here in your static, the memory space is allocated before the execution of your program, and where in your dynamic memory allocation, the memory space is allocated during the execution of your program. So the second difference between your static memory allocation and the dynamic memory allocation is, here in your static, the memory space which we had allocated is fixed. In your static, the memory space which we had allocated is fixed. So in static, which all the memory we allocate is fixed, we cannot change it, but the memory which we store in your dynamic, that can be changed as the user needs, that can be changed. So that is the second difference between your static allocation and the dynamic allocation. So the second point we have is memory space. So memory space is allocated, is fixed, and the memory space which you had allocated for dynamic is not fixed. Means we can change as the user needs. You can increase also, you can decrease also. But what we had stored for your static, that cannot be changed. Once it is stored or reserved, means over. If you want to, you even can't increase the capacity, and even you can't decrease the capacity in your static, where in your dynamic, that increment and decrement is possible. So it is called as dynamic, and so it is called as statics. Next, the third difference between your static and dynamic is, in your static, more memory space is required. In your static, more memory space is required because we don't know what exactly the elements we are going to be entered in that. For example, if I am taking the array, so we don't know that the users, how much the element they want to enter in that array. So usually we have to go for the more quantity of the size subscript for your array. For example, if we are taking the single dimensional array, we have to declare it of 50 size or the 100 size. Even the user enters only 10 elements, because we cannot expect the memory loss or the lack of the memory. Then for that reason, always we have to declare the more quantity of the memory, because later, suppose if I declare 20 and the user wants to enter the 30 elements, then we'll get the errors there. We cannot change even that time. So always what we have to do is, the memory space we have to allocate more. So for that reason, in your static, always the more memory space is required. More memory space is required. Next, coming to the point, third point in your dynamic memory allocation is, here less memory space is required. So the less memory space, in the sense, how much is required is necessary for the user, only that much of the capacity we declare, because we are declaring the memory, or we are assigning the memory to the variables at the time of execution. At the time of execution, for that reason, only the required memory we use here in your dynamic. So we say that less memory space is required. Less memory space is required. Less memory space is required. Next, coming to the last difference between your static and dynamic. In your static, memory allocation from stack area. So here, stack is a data structure where we try to enter the data in a one way, where one after the other on that top we go on entering the data. Then, so just remember, like array, stack is also one method of storing the data. Then, so how we store, how it is worked, that all we'll study in the data structure chapter. Then, so the next point here in your dynamic memory allocation is, the memory space is from heap area. So you have stack and heap comes in the method of your data structure. That time we'll study in detail, but timing, you remember, these are the methods where we try to store the data. As you try to use the arrays concept, in the same way we use stack and heaps. Then, so the fourth is memory space or memory allocation is from stack area for your static. Memory allocation from stack area, and here for dynamic the memory space is from heap area. Memory allocation from heap area. So these are the two methods, stack and heap, from where we can take the data. Done? So this is all about your static allocation and dynamic allocation. So the points which we had covered, you have to study everything in detail, because many questions will get from this memory allocation concept. What is memory allocation? Types of memory allocation, the operators which we use in dynamic memory allocation, then what is the use of new operator, for what purpose we use, where all we can use, what is the use of delete operator, where all we can use, and what is the use of this. Next, the difference between static memory allocation and the dynamic memory allocation. The first difference is memory space allocated for your static is before the execution of the program, and here it is during the execution of program. Here the memory space which we allocate is fixed, here it is not fixed, we can change or we can reduce or we can increase also. Here the more memory space is required because at the time of execution we cannot change the size, and here it is less memory space is required because at the time of execution we declare, so how much is necessary, only that much of the memory we allocate. And here the memory allocation is taken place from the stack area, and here the memory allocation is taken place from your heap area. Done? So this is all about your static memory allocation, dynamic memory allocation, delete operator, new operator, and relating to your memory allocation. Done? So many 1 marks and 3 marks questions you will get from these concepts. You have to study in detail. Next, coming to the next point, we were using a word, something called as free store. Now I'll tell you what exactly it means, free store. So I was telling you that when we are using dynamic allocation, the memory methods for allocating the memory to the variables, that time we use new and delete operator. So here when you are allocating the memory dynamically using new operator, this memory is taken by this free store, as I told you in the previous sessions also, and now when we were doing the revision on your operators, that time also I had told you. Now we'll see what exactly this free store is. Okay, what exactly this free store is. This free store is also called as heap memory. This free store is also called as heap memory. Then, so you may get 1 mark question is what is free store or what is heap memory. Don't forget, you have to study it. So here a free store is a pool of memory. Free store is a pool of memory. Pool of memory means the big area of the memory. A pool of water, how we say, a big quantity of the water will be there, so we say that pool. Then similarly, a memory pool means a large space of the memory will be there. Done. So free store is a pool of memory available to allocate and deallocate storage. This memory is used for allocating and deallocating storage for your objects, that may be the variables or the objects and all, during the execution of the memory. So the area of the memory which has been used for allocating and deallocating memory for the objects only during the execution of the time, only run time. So such memory is called as free store or heap store. Just remember, when all you want to do the dynamic allocation memory, that is using your new and delete operator at the time of execution. So that time which memory space is used, that memory is called as your free store and heap store. Right? So let me give you the meaning. Free store is a pool of memory available to allocate and deallocate storage for the object, storage for the objects during the execution of the memory. So at runtime, when you want to allocate and deallocate the storage for your objects, we use some memory. That pool of memory itself is your free store, or which is also called as heap memory. Understand? Remember this meaning for 1 mark. What is free store or what is your heap memory? Next comes is one more concept, is something called as memory leak. Something called as memory leak. So what is memory leak? Here we'll see. If the objects that are allocated memory dynamically, means you have the objects or the variables that are allocated memory dynamically, are not deleted using delete. The memory block remains occupied even at the end of the program. So what happens sometimes is, when you are using the objects for dynamic allocation, those memory which you have reserved for those objects will not be destroyed or will not be released if you use the delete operator even at the end of the program. So such memory blocks are known as orphaned memory blocks. Such memory blocks are called as orphaned memory blocks. So which are called as orphaned memory blocks? The area or the memory which has been reserved for your objects dynamically are not deleted using delete operator even at the end of the program. Such memory blocks are called as your orphaned memory blocks. And these orphaned memory blocks, when increased in number, means the capacity of or the number of these orphaned memory blocks increases, then these will bring the adverse effect on the system. And that situation is called as memory leak. So understand what situation is called as memory leak. The objects which has been allocated dynamically using your new operator, even though you use delete operator, the memory has been not released or the memory has been not destroyed. So such memory blocks or such collection of the memory is called as your orphaned memory blocks. So these orphaned memory blocks, when increases in number, if the objects which all are using in your programs has been never released, has been never destroyed the memory, then the number of the orphaned memory blocks automatically goes on in increase. And when they will increase in number, they will create an adverse effect on your system. The system will face the problem of lack of the memory, and such situation is called as your memory leak. Which situation is called as your memory leak? When the orphaned memory blocks increases in your system, that situation is called as your memory leak. So how the memory leak happened? When you are using the dynamic method to allocate the memory to your objects, and even after using your delete operator with that objects, the memory has been not destroyed. So such memory blocks are called as your orphaned memory blocks. If the number of these orphaned memory blocks will increase in number, then it will create the reverse effect. On your system, and such situation is called as your memory leak. Clear? Understand the concept, how the memory leak will happen. What do you mean by free store and heap memory or heap memory? The difference between static memory allocation, dynamic memory allocation, and what is delete operator, what is new operator, how to do dynamic allocation, that is you are allocating memory and deallocating memory. What is the meaning of your static memory allocation? Each point you have to remember for 1 marks and 3 marks. Clear? So today I am covering only these points. That is, we had seen the memory, types of the memory allocation. What do you mean by static memory allocation? What do you mean by dynamic memory allocation? Then we had seen the operators used in dynamic memory allocation, new and delete. How to use new, how to use delete, when we can use new, when we can use delete, the difference between your static memory allocation and the dynamic memory allocation, 4 points are there. You have to read all the 4 points because the question will be asked for 3 marks. You have to write compulsory all the 4 points. Next, coming to the next point we had is free store. What do you mean by free store? The free store is nothing but a pool of the memory which is available to allocate and deallocate storage from the objects during the execution of your program. So when all you want to allocate or deallocate the memory dynamically, that time from where we use the memory, that memory is your free store. Then next comes one more point is memory leak. When you are allocating the space dynamically to your object, then even though using your delete operator, the memory will not be released and the memory remains like that only, reserved. Then so that memory cannot be used further for the next other objects also. So if the number of such memory blocks will be increased, then it will create a reverse effect on your system. The system may hang, the system will not work, stop working, like that some situation happens, and that situation is called as memory leak due to the loss of your memory. Like that any effects will happen, that is called, and such memory blocks are called as orphaned memory blocks. Done. So these many points I had covered in today's sessions. You have to study each because those all are important for your 1 mark and 3 marks. So only few points left out. I try to cover in the next class. If you have any doubts relating to this, you can ask me. I'll stop the session. Thank you.